Hey, I'm Mitchell, and welcome to another video in the RSP Education series. Every electrical system, whether in your home, an industrial facility, or a power grid, relies on one critical component to keep things running safely, and that's the circuit breaker. But what exactly does a circuit breaker do? Why is it so essential? In this series, we're going to break down the fundamentals, the mechanics, and advanced applications of circuit breakers so you gain a full understanding of how they protect, control, and enhance electrical systems. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional always for your application. RSP supplies not liable for any misuse of this information. With that said, let's get right into it. So what is a circuit breaker? At its core, a circuit breaker is a safety device that's designed to prevent damage to electrical circuits by interrupting the flow of electricity when a fault occurs. Think of it as a highly responsive security guard for your electrical system. When it detects an overload or a short circuit or some sort of fault condition, it quickly shuts off power to prevent fires or equipment damage or other electrical hazards. So why are circuit breakers so important? Well, without them, electrical systems would be at constant risk of overheating and failure. Before modern breakers, electrical protection relied on fuses, single-use components that had to be manually replaced after every fault. Circuit breakers, on the other hand, revolutionized this process by allowing for automatic resetting and more precise control over power distribution. So how do circuit breakers work? At a deeper level, circuit breakers, they operate by detecting abnormal current conditions, and then they mechanically break the circuit. Most breakers use thermal or magnetic or electronic trip mechanisms to sense faults and react accordingly. For example, a thermal trip, it uses a bimetallic strip that bends when heated by excess current. This triggers the breaker. With a magnetic trip, this relies on an electromagnet that activates when a short circuit causes a sudden surge in current. An electronic trip uses sensors and microprocessors for more precise fault detection, and it's commonly found in industrial applications. So let's get to understanding circuit breakers a little bit better in industrial automation. Circuit breakers, they're critical protective devices that safeguard electrical systems like machinery and control panels from damage caused by overcurrent conditions like short circuits or overloads and even ground faults. These issues are going to lead to catastrophic failures, equipment downtime, and safety hazards if not properly managed. So let's talk about now how circuit breakers protect industrial equipment, specifically understanding overload in industrial automation. So in industrial automation, overload refers to a condition where an electrical device, typically it's going to be a motor, where it draws more current than its rated capacity for an extended period. This excessive current is not due to an electrical fault like a short circuit, but instead something like a mechanical or operational condition that forces the motor to work beyond its designed load. That wraps up our introduction to circuit breakers. We covered the fundamentals, which are what circuit breakers are, how they work, and why they're essential for protecting electrical systems from overloads, short circuits, and faults. From the thermal and magnetic trip mechanism to the evolution from fuses to modern breakers, you now have an understanding of why these devices are so crucial in electrical safety and reliability. But that's just the beginning. In the next video, we're going to take it a step further. We're going to dive deeper into how circuit breakers handle overload conditions in industrial automation. We're going to discuss what happens when a motor draws too much current. How does a breaker know the difference between a temporary surge and a dangerous overload? And why is thermal trip protection critical in preventing costly equipment failures? We'll walk through real-world scenarios like a jammed conveyor motor in a motor control center and break down exactly how circuit breakers detect and respond to overload conditions before damage occurs, hopefully. So if you're ready to see circuit breakers in action, make sure to subscribe and stay tuned. We're just getting started. For a full line of circuit breakers and hundreds of thousands of other industrial automation products, go to our website, rspsupply.com, the internet's top source for industrial hardware.